electronics technique. So in this video we discuss about 1/8 demultiplexer. So it is a combinational circuit. It has 1/8 means 1 input and 8 outputs. So demultiplexer means it consider only, it is the reverse operation of multiplexer. So here we can observe in the block diagram. So it is 1 input and 8 outputs. So 8 outputs. 8 means 2 power 3. The power is represents the select lines. Every time we discuss about that. So the 3 select lines are S0, S1, S2. So it is about the block diagram. So for every different combination of select lines, the input is presented one of the output. If the select line is 0, 0, 0, then input is presented Y0. Other values are becomes 0. If the input value is 1, then input is presented output Y1. So the remaining all bits are going to be 0, means Y0, Y2, Y3 and so on up to Y7. It is a Y1, Y2 and so on up to Y7. Like that, at every different combination of select lines, the particular input is presented one of the output and remaining all outputs are going to be 0. Like that, this demultiplexer is going to be 1. So now you can write the code module followed by module name. And what are the input ports here? So what are the input ports here? So there is a 1 input port and 3 select lines. These are also input. So input I. So to represent the input port, we simply write input keyword input I comma. So they are the 3 select lines, S of 2, S of 1, S of 0. So we can represent in vector format 2:0 of S. Output. So what is our output? There are the 8 output ports. So we can represent in vector format. So how we can represent 7:0? Means 0, 1, 2, 3, 4, 5, 6, 7. So 8. These are out variables. So out of 0, out of 1, like that it all be represented. So why you use reg means when you are use the variable, what are the variables here? Inside the always block we use out variable here. So whenever the variables which are used in the always block or initial block, we make it as a reg data type. So that's why we make it as a reg data type. So always at the rate, this is called sensitivity list. So inside the sensitivity list, you represent the inputs. So if any change in the input, you are going to be execute this block. If you represent star means it represent whole inputs. So all inputs, what are the inputs we take? So all inputs are considered as star. So if there is a multiple statement, you start with the begin keyword and case. So we all know about the case statement. So case statement is like this. Inside the bracket you represent any variable. So yes. So for this variable you can give different values inside this case block. So if there is equal to particular value, then that particular line is going to be executed. Otherwise if the value is going to be 1, so this line will be going to execute and case will end by end case. So here see, if the select line is equal to 0, the out variable is like, here you can observe. So you can simply write like this. So what is the size of the output port? 8. So 8 bit, binary means B. So what is our truth table? Whenever the select line is equal to 0, so only Y0 will be going to be our data, means 1. Here I represent data as 1 and non-data as 0. So you can simply represent the out of 0 be 1. So remaining all are going to be 0. So for every 4 digits we use underscore for our easy understanding. So if you don't mention also, no need. If you mention like underscore also, it consider it as 0, means it consider it like this. So 4 zeros followed by 0001. So these both representations are same, but while you are using this method you are getting confused how many zeros you mention like that. If you use this means it is very easy to understand while seeing one time at a time. So like that, for different combinations means select line is equal to 1. The 1 means out of 1 will going to be 1. Remaining all are going to be 0. If the select line is equal to 2, out of 2 going to be 1. If the select line is equal to 3, out of 3. Like that, we can write the all combinations here and begin will end with end and module stop by end module. So it is about our design code. So test bench code. So module. In test bench code also same like design code, start with module and end with end module. So module followed by module name here. So it is our module name. So the syntax of the test bench code is like input ports are in reg data type. So outputs are be the Y data type. So why we are using reg data type means there is a reason. Means I already say that what are the variables we are using in the always block or initial block. So what are the variables we are using? It is going to be the reg data type. So that's why we make it as a reg data type. So otherwise we can use wire also, but because of initial block we make it as a reg. So input, what are the inputs? I and the S. So you can simply write reg I, reg 2:0 of S. So while 7 down to 0 of out. So next we have to connect the design code with test bench code. So design code with test bench code you can connect means you have to instance here. So how you are going to instance? So write the design code module name here. So it is our design code module name followed by instance name. You can write any name. DUT is mostly used in Verilog code. So you can use your name also, no problem at all. So it is our port connection. So it is by port connection by order. It is a port connection by name also. This full length video will going to be done already in the previous videos. If you don't watch, go and watch that video, then you can understand properly. So it is about port connection. So it means these ports, what are the ports in the test bench code ports, are going to be connected to the design code ports. That's why you use this port connection. So in the initial block we are giving different combinations of inputs and give some delay between the inputs. So here you can start with initial. There is a multiple line, so that's why followed by begin. So first you can give I value like that, and you can give select line and give some delay. Again you can give different combination of I and S, and again you can delay. So again you give some different input combinations, and again you can delay. After certain period of time you want to stop the simulation, then use the finish keyword. By using finish keyword you can stop the simulation. So this begin will stop by end keyword. So these 4 lines are used to generate the waveforms in EDA playground. So if you done this code in any Vivado tool like that, so no need to write these 4 lines. So otherwise in EDA playground means you must write these 4 lines to get the waveform. So if you don't need to show any waveform, then no need to write these 4 lines. So stop with end module. So after this you can run means the output will be show like this. So here you can observe that what is the line here, it shows the values here. So if the here I is equal to 1, so if the select line is equal to 7, so what is the going to be done? See here, if the select line is equal to 7, see here, out of 0 will be going to be 0, out of 1 is going to be 0. So you see here, this is 0, this is 1, 2, 3, and underscore is negligible, 4, 5, 6, and last one is 7. Means out of 7 is going to be 1. So now cross check whether you are correct or not. So out of 0 is 0, out of 1 is 0, 2 0, 3 0, 4 0, 5 0, 6 0, 7. So whenever the select line is equal to 7, then our input is going to be presented out of 7. So S, it will be correct. So remaining all are going to be 0. You can cross check whether it is correct or not. Yes, all are 0, but out of 7 is going to be 1. So your answer is correct. So like that you can verify your program is correct or not, or design code is correct or not, whether your test bench code is correct or not. If you don't get any proper values, then cross check your design code and test bench code once more. Then it will be getting errors is no problem. While doing number of times and getting errors also give solutions, and next time you can improve better than before. So if you have any doubts you can comment it. If you get any errors you can unsolve that. Use ChatGPT and any open source. Then also you don't get any answer, then you can comment on it. And until then, thanks for watching, and then bye.